Hi everyone, in this video we are going to learn about center of mass. So these are few important formulas and in this page I have kept few basic formulas which we need to know. Yeah, R is equal to M1 R1 plus M2 R2 plus M3 R3 so on by M1 plus M2 plus M3. If in the question there is no R1 given, so you should implement this formula like M2 by M1 plus M2 into D. If you need to find R2 is equals to M1 by M1 plus M2 into D. If you need to find center of mass, xcm is equals to m1 x1 plus m2 x2 by m1 plus m2. So this is the basic formula for the center of mass. Angular displacement of the particle denoted by theta. d theta is equals to ds by r. R is the distance or the radius given in the question. Now angular velocity is denoted by omega. Omega is equals to delta theta by dt or d theta by dt. d theta by dt is equals to 1 by r ds by dt, which is a so we are relating this with this formula with this formula. So you can find the difference like d theta by dt is equals to 1 by r ds by dt. dt is common on both sides. So d theta by dt is equals to omega, as we said just before a second. So omega, which is equals to rate of change of distance by time, is equals to velocity v, as it is r. Omega is equals to v by r. So v is equals to omega into r, and omega is also represented in the form of time period like 2 pi by t, which is equals to reciprocal of time is a frequency 2 pi nm. Magnitude of angular velocity is called angular speed, which is represented by omega. So angular velocity is known as angular speed, represented by omega. Now momentum of inertia. So this is the basic formula. I is equals to mr square. If you are given multiple masses and multiple radiuses, so this is the formula. I is equals to m1 r1 square by plus m2 r2 square so on. And next is the radius of gyration. In radius of gyration, I is equals to mk square, whereas k is equals to I by m root over. So this m goes down and root comes up. It forms like k is equals to root I by m. So this is the small diagram which is represented, which represents the gyration. Next is parallel axis theorem and perpendicular axis theorem. In parallel axis theorem, this axis up parallel to each other. So this is radius of gyration denoted by ig, and this is the distance between two axes, so denoted by x, and the particle moving around is and the distance between these two is represented by a, and the distance between the axis and the particle is represented by r, small r. So I is equals to mr square. This is the basic formula, and ig is the radius of gyration, which is equals to ma square. So I is equals to mg plus mx square, where I is equals to mr square, which is equals to ig is equals to ma square plus mx square. So in this m is common. You need to take m as common and bracket a square plus x square. So this is the main formula. Let me underline this, highlight this. Yeah. And next is perpendicular axis theorem. In this, all the axes are perpendicular to each other, where the angle between them is 90 degrees. So ig is equals to iz is equals to ix plus iy, x, and y axis y. So iz is mr square, which is equals to mx square, the distance of x axis, my square, distance of y axis. And there is a small topic here we need to discuss. Mu is equals to reduced mass, and mu is represented by m1 into m2 by m1 plus m2. So I is equals to mu into d square. This is very important formula. I is equals to mu is represented by m1 into m2 by m1 plus m2 bracket d square. And next is these are few basic formulas like we have also learned it in 10th class or in 9th 10th. So momentum is represented by p, which is equals to mv. So this is linear momentum. In angular momentum, p is denoted by l and m is denoted by v is denoted by omega. So l is equals to I omega. So I omega or mv is denoted by mvr. So we are I'm also gonna tell about this in this formulas. Just wait. Aerial velocity dA by dt, which is equals to L by 2m. So this is the formula, and which is equals to I omega by 2m, which is equal, just now I said I omega is equals to mvr, and as it is 2 into m, which is equals to mm gets cancelled and it gets as vr by 2. So just remember this VR by 2, this is the important thing. And if I omega is constant, I1 omega 1 is equals to I2 omega 2, whereas omega is represented by 2 pi by t or 2 pi by n, as it is I into 2 pi by t, that is 1 and 1 if it is written as 1, which is equals to I2 2 pi by t2. I1 into 2 pi into n1 is equals to I2 into 2 pi into n2. So reciprocal of t is n, which is known as frequency, where 2 pi gets cancelled, and it is also simplified. We can also simplify it in a simplest manner. And the work done is a force into displacement, F into S, which is equals to tau into theta. So kinetic energy is equals to half mv square, and in this chapter we represent it as half I omega square. M is denoted by I, V is denoted by omega. Work energy theorem. So according to the work energy theorem, this formula is also converted into this way, like work done. W is work done. This is W, not omega. Yeah. W is equals to F into S, which is equals to half mv square minus half mu square. And F is denoted as tau, as we said here, into theta is equals to half I omega square minus half I omega naught square. So power is work done by time. So work done by time, we get it as force into velocity. Work done is force into displacement, F into S by t. S by t is velocity. So force into velocity, which is equals to tau into theta by t, tau into v. E is equals to momentum square by 2m, whereas E is equals to, just now I said that P is equals to L, and in the place of P we need to substitute it as L square by 2I. M is denoted by I. So this is the formula of center of mass. Here we end the video.